Hello, I'm Mike Mensch, Business Development Manager at Princeton Consultants. Thank you for joining us today for a webinar with my colleague Patricia Randall about embracing Agile for optimization. We will be sending slides and a recording afterwards. Please post any questions in the Q&A box at the bottom or in the chat, and we'll address them at the close of this webinar. Now, I will turn it over to Patricia.
Awesome. Thank you, Mike. Thank you, everyone, for joining today. I'm really excited to talk with you what is becoming, I think, an increasingly hot topic as optimization and modeling really becomes an integral part not only of a company's applications, but really of their technical stacks. And that means they kind of want it to follow along with their technical platforms in the way that they do technical projects. And so we're seeing more and more conversations about Agile and how do we do optimization projects using Agile, and what are the challenges specifically for optimization and Agile. So looking forward to that discussion today. First, though, a little bit about me. Okay. So I'm Patricia. I've been at Princeton Consultants for 17 years, and I focus on leading a lot of our optimization, modeling, simulation, AI, and ML projects. This is a big focus of our firm, and my favorite thing to do. I love working with our clients to implement optimization and modeling into their real-world applications and really be able to impact their decision-making as part of that. Our firm is an information technology and management consulting firm. We've been around for 43 years. We have, as you can see, 1,800 successful completed projects. I guess we'll be nearing 2,000 pretty soon. And we do a lot in the transportation and supply chain space. We work a lot with rail, trucking, different verticals, flights, airplanes. But we do generally cross various verticals and industries. And really what we're looking for are interesting problems that we can help people make better decisions, bring optimization into their decision-making process, and really just improve not only their decision-making, but their jobs as well. And just really 24/7 kind of critical support things. We want to help you be impactful in your day today. So before we talk too much about, what is Agile, let's think back about waterfalls. So a lot of us, myself included, came up more on the waterfall approach for development, right? So waterfall is great in that it seems very structured. It looks beautiful on this chart. We've got our requirements, then we do our design, that leads to development. We do our testing. Hopefully we've got some good user testing in there with that. We go ahead and deploy it, and then we give it to our users for final review. And then we're like, there you go, you've got this application. That looks really clean. It flows really well, as water does. But there are some clear advantages and disadvantages. So advantages are their stages. I mean, look how great that looks. It's very easy. We've done our requirements, check. We've done our design, check. Very easy to check the box on each of these things. In terms of management, it's a pretty straightforward process. Again, you've got your requirements phase, it lasts X time. You've got your design phase, it lasts Y time. Very clear gates or milestones between those. Very defined scope because you do all the requirements up front. And so if you get all of your requirements up front, in theory, you will know your entire scope. So in theory, you come out of step one and you know everything you need to do. It may take a long time to do it. You may be working on these further steps for a while, but you've got your starting blueprint and you are ready to go. You have strong clarity around that. And waterfall tends to have very comprehensive documentation. I remember when we were doing more waterfall projects, we would have functional design documents that were easily 100+ pages, and they had screenshots, and they had the model formulation and business logic and all the things that this application was going to do written into a document before we had even begun development. Same with the technical side. We would do these huge documents full of actually all the service definitions. So if I have a RESTful API, what is every service call? What are the parameters it takes? What does it return? All of that spelled out before anybody starts coding. The nice thing about that is, at least in the beginning, you have very strong documentation. It's all in one place. The issue with that is if, as things move along, people don't always want to go back to those 100-page documents and figure out what needs to be changed. So it's comprehensive, but it tends to get stale pretty quickly. Some other disadvantages to waterfall. A big one is late issue discovery, and this really comes through the second one, which is lack of user feedback. So if you think about a traditional process, we went and we did our requirements, we sat with our users. We love to sit with our users. That's my very favorite part of the job. I want to learn your business so I can model it for you and create an optimization model that's really going to help. So we went and sat with our users, and they told us everything that they thought we needed, that they told us what they needed. So we wrote that all down. But what if they forgot something? Or what if something only comes up when they start to see later the results or the solution or the data? Well, now you've got this whole set of requirements and it's missing pieces. So when you think about like your comprehensive documentation and your clarity of requirements, you only know what you know, right? There are pieces that you may have missed that you don't realize until further into the process. So you do risk misalignment. You don't always have the user feedback. That's not to say you can't do user feedback in waterfall. It's just not built into it, right? Into the process. You're not typically going back during design and development and talking to the users. Hopefully, when you get to test, you're doing a really good UAT. But at that point, again, you've already developed the entire system in theory, right? So to go back to even just the requirements, you're almost starting over. And then it's a pretty inflexible process, as you can expect, because anytime you hit one of these milestones and things suddenly change, like let's say your business process changed, you've got to go back to the beginning and start again. So while it seems like a very neat and tidy approach to software development, it can really lead to inflexibility. You actually end up doing a lot of rework, unfortunately, or even resulting in systems that people can't use. Now, even the creator of the waterfall method, Winston Royce, recognized the risks of this. So he says, I believe in this as a concept, but the implementation is risky. This is actually a quote from when he was laying out the waterfall method. Because everything is based on these requirements. The design is based on the requirement and the rationale. And if you need changes, they're going to be very disruptive to the process. And disruptive is a great word for it because when you have to stop and restart and stop and restart and possibly throw everything out, that can be very disruptive to what is going on. So this was a method that people used for many, many years. It's very popular. It's kind of the default way of doing software development for a very long time. But let's look at an alternative approach and let's look at the history of Agile. So in 1970, this was when Royce really coined the waterfall method. So that's been around for a while. 1990 was when the Scrum process was first really conceived. So that's when the first talk about doing Scrum came about. So you can see that was 20 years later before we even started to talk about Scrum. And then in 1995, there was a report by the Standish Group, and this really shone a very bright light on the cost of software failures. And it can be hard sometimes, I think, to really wrap your head around what it costs when software has to be redone. And it seems obvious, you can go figure it out, but really, it's hard to really say, okay, this is costing us, because we missed these requirements, it's cost us this amount of time, this amount of dollars. So this report actually attempted to do that. And what it found was that many projects using waterfall, which was the standard at the time, were actually failed. And that those failures cost a lot of money. And this report actually really raised a huge alert, which in the industry, that's technology and software industry, of, hey, this is not working. We can no longer imitate the three monkeys, hear no failures, see no failures, speak no failures, because the risk is very great. And this is having a huge impact on the economy of the United States. In fact, they said that a staggering 31% of projects will be canceled before they ever get completed. Not that they won't work or that people won't use them, but they'll actually be canceled. And then further, 52% will cost more than 189% of their original estimates. And this is like a huge cost, $81 billion at the time. This was in like 1995. And when you are doing waterfall, it's very easy. You can see how you could overrun projects and you're finding requirements late in the game. You've got to go back in the process and start again. Hopefully you can kind of shorten it, but not always. Sometimes you're doing a full rewrite. But also when you have a project that can take years, and a lot of times a waterfall project will take years, and in those years you are not seeing a lot of interim results as a business owner, it can be easy to kind of lose interest in a project and say, I don't know if we need to continue. Like, what am I getting out of this project? It's been going on for 2 or 3 years. I keep getting these new requirement documents. They keep pushing out UAT and delivery. let's just not move forward with it. And so it's very easy to just give up on it because it takes a long time, just naturally, because of how you go from one step to the other. And you don't see anything you're just trusting people to go off, code it all up, and bring it back to you. And so it's easy to say, yeah, you know what? Maybe this isn't as impactful as I thought. Maybe I don't want to wait. Maybe there are other ways to do it. During that time, I found an alternative and it's working pretty well. And so the risk of not only having to redo work, but just people saying, I don't need it anymore. That's a pretty big risk. So because of this report, this group got together in 2001 and they came out with the manifesto for agile software development. So this is when we first start to see the term agile. So again, 1970 we had waterfall, 2001 we had agile. I was not aware of agile in 2001. It was not on my radar at all. It would be many years before we were asked at Princeton Consultants to do agile projects and asked to do them regularly like we are today. Then in the early 2000s, Scrum really emerged as the dominant Agile framework, and there are other frameworks that you can use in Agile. Scrum is the one that we see most common. It's a pretty organized framework. It's very easy to understand, very easy for teams and to build up and build down and scaffold. And so we do still see it today as the most popular Agile framework. Then in the 2010s or 2010s, we saw really the introduction of DevOps and CI/CD. This is really important because with Agile, you're talking about releasing on your sprint cycle. So, and we'll get into a little bit more detail about Agile, but if you're trying to release stuff as quickly as you can, you need a really good set of technology to help with that. You need your pipeline. You need really good testing because you're going to be releasing a lot. So you're going to be testing a lot. You need to have all that DevOps. And for clients that I've seen that want to do Agile, but they haven't firmed up the DevOps piece and the CI/CD piece, it is very painful to really see that agile process as it should be because it just takes too long. It really lengthens out that cycle. It produces an enormous amount of overhead on the team. So that was a really important piece where I think to really help people start to implement agile in actual corporate America. And then in 2018, Harvard Business Review published Agile at Scale. And at this point, Agile really became mainstream. I will say, looking back, I think about 2016 was the first time that I started working really with Agile for optimization. And I was a little resistant to it at first. And I'm sure some of you, if you face that, were resistant to it as well. There's some scary factors about it. But we do believe that it can be done successfully for optimization models. And that's what we really want to talk about today. How do we overcome our fear and some other issues that we have with it? So we talked about the timeline, we talked about waterfall, let's talk about Agile. So Agile is really meant to be very flexible, very iterative. You're doing small incremental releases of the product. You're basically almost always constantly releasing, it feels like, depending on the length of your sprints. But what it really emphasizes is collaboration, feedback, adapting to changes. It does inherently take a little more technical debt because you're not designing everything up front, and that's an accepted part of Agile that you will occasionally rework things because of that. So you have much faster iterations. You're getting things to people quicker. You have very frequent validation and user engagement. You've actually got a role on the team called the product owner, who is intended to be a business person, and they are an expert in the business process, and they are to give you every sprint feedback and to work with the team on what are our priorities, what do we need to work on, is this working, is this not working, how can we tweak things? So you get very frequent validation. You're not waiting through a 2-year development cycle into UAT to get that first business feedback. You're getting continuous improvement because you're in this loop. You're doing something and delivering it. You're reflecting on it. You're delivering something else, reflecting on it, delivering, reflecting on it. This can lead to some disadvantages. Obviously, the timeline and costs are uncertain. You kind of like, you know what done means, and we're going to talk about what done means in Agile for a sprint. But it can be harder to see the finish in Agile than in Waterfall. I will argue that in Waterfall is actually a bit of a fake finish because you're assuming that all your requirements are 100% there, they're correct, and they're all fully captured, and that is often not the case, as we have seen. But in theory, with Waterfall, you see exactly where you're going, and you see how to get there, and you're like, I've got a plan. It's like a 2-year plan, it's a 3-year plan, but I've got a plan. With Agile, in theory, your product owner can give you a different priority every sprint. And so it's hard sometimes to know when you're going to wrap up. When are you going to finish and get to that point where you're like, this works great. I'm happy. It's got everything I need. We can talk about some of that later in this presentation. I will say this is particularly an uncomfortable conversation sometimes when you are like me, an outside consultant working with a corporation, and they kind of want to box in, how long you can be working on this. You've got an SOW, maybe that SOW is for a year, and how many sprints is that, and will that complete everything? So that can be kind of tough. Inherently, Agile also kind of invites scope creep. In fact, we wouldn't even consider it scope creep in Agile typically, right? That's just the Agile process. But if you're kind of looking at it from, as 30,000-foot view, you're like, I can see how more and more stuff is coming in. It feels more scope creep than waterfall. Again, that's because you're adjusting to what your business and what your users need. And so it's not really scope creep. It's delivering a product that they need and can use, but kind of in the old waterfall, or I need to know what our requirements are kind of thinking, that would be, in a way, scope creep. There is a potential for fragmented vision because, again, you're kind of planning on a sprint basis, which the most common sprint cycle I see is 2 weeks long. So you're planning 2 weeks at a time in theory. And so, yeah, you could see how you could kind of get fragmented. You work on something and something new becomes important or shiny, and you work on that, and you've kind of left the other thing and you're moving to a third thing. Do you ever get back to the first thing? So you kind of have to have a vision even on a sprint cycle. And then I have personally found that there are still a lot of meetings with Agile, and there's, of course, heavy client involvement, client being your customer, your product owner. And that's actually intentional and it's important to the process. But I think sometimes people think Agile is this light lift on the team. It frees the team up, and it does in a way. But we have to remember that now we have, 4 or 5 sprint ceremonies, and they happen every sprint. And there is a lot more interaction. There's a daily stand up, you've got your demo, you've got your refinement and your grooming and your retro. And so I would argue that it's about the same amount of time, but perhaps more consistent than what you see in waterfall, which tends to be more bucketed into like the requirements and the testing phase and kind of a bigger open space and design and development. Now, one thing I want to say before we get into really Agile for optimization is Agile does not mean that you don't know where you're going. So I know people think of Agile and they're like, I don't even know what we're going to do next sprint. We got to wait to see what the product owner tells us our vision is. We'll have no idea. It could be something completely we've never seen before. And that's just not really how I've seen Agile work, even outside of the optimization space, just in software development. You typically have an idea of what your business objectives are. What are you trying to achieve? You need to have your big picture focus because you do want to go down a path that's going to get you to where you want to be. You want to know what are your features that you want to prioritize. And also, a lot of times you're not working in a void with just your team. You've got dependencies in other teams in a corporation or even outside. And so you have to figure out what are our dependencies and when do we bring those teams in. Something that we've seen work very successfully is the PI planning, program increment planning, which is a big part of the SAFe framework. This is done, we do it every quarter, and that's pretty typical. And you're planning for the quarter ahead, and you say, okay, what do I want to accomplish in this quarter at a high level? Maybe what are the epics that I want to achieve? And then who's going to be involved in those epics? Maybe I need to work with the database team. Maybe there's this other team that needs to feed me some data. Maybe there's a third team that I'm feeding stuff to, and I need to understand what their requirements are for me so that we can plan for them. And so I would definitely encourage people not to go in and just say, oh, we don't need a roadmap anymore. We don't need a project plan. You might not be doing your Microsoft project plan anymore that has the detailed tasks, but you at least need to understand the big picture of where you're going, when you're going to need to bring other teams in, kind of how you want to prioritize things, particularly with an optimization model, because optimization models are not as independent in terms of pieces as it might be to say do a UI, right? Where you're doing different screens and different buttons and, we can do this or not. When you get into optimization models, it is still one big thing that needs to all be delivered at the end. And so definitely want to encourage people to think about how to build that kind of roadmap planning into the process and to know that that's a totally acceptable and done, part of Agile. And so not to just think we're just going to wing it every sprint and hope that at the end we build a model that actually does something. So we've talked about Agile. What is it? Why did it come about? Is it saving the technology industry, software development? But why for optimization? And so, like I said, when we were first starting to work with companies who wanted to do Agile for optimization models, it felt a little bit different and challenging at times because it's just such a departure from the waterfall method, which is, I think, how a lot of us learn to do optimization models. Like if you think of an optimization model, you do the formulation, you look at your data, then you code a model, then you start looking at the results. And that's a very waterfall step-by-step process. Now in Agile, we're talking about doing these in iterations, but we have really come around to that. I actually think it's a great way to do optimization because I think it solves some of the challenges that we face in optimization models. They're complex problem spaces. There's often a lot of variables and constraints that actually require really frequent recalibration. Um, Something with a model is that if you add a new constraint or a new objective or a new decision variable, suddenly things that worked really well may be slower or they actually may not be working at all. We've seen those challenges with clients where they're really happy with the results and they want to add another piece in, and suddenly we've got to recalibrate everything. We've got to retune everything, adjust the way we're doing objectives, maybe even reformulate things. And so the agile process is actually a way that we can step through that in the methodology and not wait till the end to be like, oh man, we got to go back and rework this. That flexibility in development is really helping us. Also having the faster iterations, because that means that we can release partial solutions and see, do people like them? Are they finding them useful? Something that I think has always been a challenge with optimization is wanting to get user feedback and validation and trying to get that frequently in a way that's not a burden to the users, but that is also not just performative and check the box, right? Like if I give you as a modeler like a spreadsheet and here are the results for this test data set and you're not really sure what to do with it, you might kind of look at it and you might say, that looks okay. I think it's fine. I don't see anything glaring, right? There's no huge constraints broken. But then if I give it to you in a tool and I say, okay, go make a decision with it, then suddenly you're like, oh, whoa, whoa, I can't use this solution at all, right? There's this and that, and I would never do this. And the time I told you we always do this, but we don't always do that. Sometimes we do that. And that kind of thing, it's really hard to do if you're not getting realistic results in front of your users frequently. Instead, you risk waiting till the end to get that kind of validation, which again, we have to start our cycle all over again. And the thing about Agile is bringing those users into the process as early and as often as we possibly can. And so to me, what's always been the holy grail as a modeler is time with my users, time with the business, time understanding their problems, and even more importantly, time understanding what they like and don't like about the solution. That can be the hardest thing to get. Do you like a solution? Yes or no? And if you don't, why? So that we can fix it and make it into something that you can use. And I think Agile helps with that because you're bringing them in constantly, trying to get that feedback. They are deputized, really. I mean, they're part of the team. That's actually their job, their role to do that. So I think that's been really great and really allows for continuous improvement versus waiting till the end and hoping that everything works out. And another thing with evolving user requirements, again, a lot of times it sounds really neat and tidy to have all the requirements up front. And we as modelers, we love our model formulations. Who doesn't love a good math document, right? A ton of equations in a LaTeX file or mark them. And we're like, here's the whole problem. I wrote it in math. It looks really great. I'm very excited about it. Everything looks really neat and tidy. And then we give it to our users as results and things don't always work out so well. I think that Agile has really allowed us to address those evolving user requirements, to be able to iterate on them, to be able to put them in layers versus delivering one big chunk at the end. And that increased user engagement has helped with that as well. That doesn't mean that these things are all easy to do, but I think these are all ways in which Agile has really helped us meet some of the challenges that are a little more unique to optimization models than, say, your traditional software development. And it's really because it's embracing the complexities and the evolving nature of these models. And that's leading to better outcomes and better user satisfaction. And so it actually feels to me like a pretty natural alignment once you kind of get into the details and overcome some of the resistance to it and maybe some of the challenges that we typically face. I wanted to give a couple case studies just to show you that we do, there are examples when it's really helped us out. What are some of the areas? One thing, definitely faster delivery of value. So we had a client who was maximizing ad slots to advertisers. So they had a bunch of TV ad slots. You're watching, football or whatever the hot show is of the week on Thursday night, and you've got some really primo spots. Then you've got some spots that are maybe movies or reruns or, channels that people are not as interested in. And how do you assign those to the various people who want to sell cars and fast food and soda and clothes and whatever else, cell phones, so that you are getting maximizing the expected outcomes for those advertisers within their budget. And really, as somebody who owns those spots, maximizing your outcome too, right? Because you're obviously trying to get the most for it as well. This client initially wanted a very complex model. There were multiple objectives, which is fine because we almost always have multiple objectives. It's pretty rare to not have multiple objectives. But some of those objectives needed data that didn't really exist. Like it kind of existed, it wasn't formalized. That they could get us a pool of that data, and then we'd have to go clean it, and it would take hours and hours. A pretty big data set to clean, so it really wasn't ready for prime time. We could not have done a model right then with that data and that objective. So what we were able to do instead is let's take a look at our MVP, which typically means minimum viable product. I like to think of it as maximum because it's really the max you can deliver at with this one initial chunk. But anyway, what's our MVP? What objectives can go in the MVP that will give you the ability to at least get started with this, start to make decisions with it and make better decisions while we work through the change management required to get that next objective. So we were able to carve out some of the objectives. They were a little bit easier, straightforward. They already have the data, deliver that, and the client could start using that. They could start seeing how the model was going to work and understand it. And in the meantime, we could work on getting that other data, and they could work on with their users figuring out, okay, now how am I going to bring users onto this new platform? Because a lot of times these models are going into either processes that have to change or new processes that have to be created. So there's often a lot of organizational change management that goes along with the new model or an updated model. And that takes time. Definitely bringing people on and training them and getting them used to using a model, used to that kind of change in their process can take time. And so this gave them the opportunity to do that while we also worked on sourcing the data. And then we could add that in later iterations of the Agile and later sprints. Another one that I really like is we've talked about this a lot because I think this is really important. It feels like you are mandated to have user engagement with Agile, and I love that because that's what I want. I want user engagement. So this was a client where we were going to optimize the allocation of railcar fleets to meet their demand and to minimize empty miles and unused rail cars. And so this was a pretty big problem. A lot of factors at play, some data cleaning at play as well. And so what we did is we focused first on a small data set with a few customers in a limited network. And this let us really be able to get in the important constraints and objectives and show it to our client right away. And this was actually, I think, what I felt like at the time was one of my most successful MVPs. But it was funny because what the user told me, this is a direct quote, we were in a meeting showing them the very first results. They said, "That's not bad." As a modeler, I'm sure we're all thinking, what do you mean it's not bad? This is perfect. But actually, I thought that was so great. I was like, breathe a sigh of relief because this user was maybe a little bit of a skeptic, right, about whether the model could be successful. Often we hear people say, oh, you can't model this problem. That's too hard. I was hearing that even when I was in school looking at really basic problems. People just don't believe that they can be modeled or solved like that. And so this allowed us to get something in front of a user where they could see how it was going to go together and how it could be better with bigger data and a more rich model. But they could see the beginnings of it and really start to buy in on that and be like, yeah, you know what? I can't see how this is going to be beneficial. And that's not too bad. And that was a pretty big win for the team. We were high-fiving after that. So I do like how Agile really basically makes your users work with you on a day-to-day basis. And I think that's a huge benefit versus going away and doing your own thing and then kind of throwing it back over the wall at the end, like you sometimes see with waterfall. And finally, I think another thing that it can really help with is early issue identification. So we were working with a client who had a product that needed to flow through a manufacturing facility. This was a product that was customized for patient needs. And we were scheduling facility and assigning machines accordingly. And so something that we had initially talked about was whether we were going to include the optimization of staff in that scheduling or just the facilities and the equipment. And we agreed that we would only do the facilities and the equipment. We wouldn't do the staff, which of course is an extra layer of difficulty. And so by looking at those results after that, what our product owner and our SMEs could see was that these schedules just weren't working because they didn't have the staff included in them. We had to have the staff. And so that gave us time to go back and add in the staff in later iterations versus waiting until we had built out the entire thing and presented it to users and then saying, oh, you know what, without staff, this makes no sense. That allowed us to catch that much earlier in the process than I think we would have earlier otherwise. And so I think that's a big benefit as well by showing people results as quickly as you can, even though they may be partial results, they may not be the most optimal results or the most complete results, you start to get feedback much earlier in the process. So now we've kind of talked about some examples that have worked really well. What are some key practices for using Agile for optimization? Iterative development, you want to break the model down into smaller manageable components. That's obviously a hallmark of Agile. What can we deliver in a 2-week or 1-week or 4-week or whatever sprint? You want frequent validation. You want to be testing and validating model outputs with stakeholders at the end of every sprint, even during the sprint. Continuous integration. So continuous integration means you're always able to deploy whatever you put in. Now, this is the challenge for sure with any piece of application, particularly with models, is how do you keep from breaking it as you add new things? And we can talk a little bit about that in a couple slides because that is the challenge. But you want to be continuously putting out advances to it. And then a user-centric approach and really engaging frequently to gather feedback and adjust the models to better meet their needs. I will say, I think it's really important as a modeler, especially if the group that you're working with hasn't done Agile for optimization before, is to really think about how you may need to customize the process. I think Agile is, pretty well defined for typical software development. I don't think that you need to necessarily adhere to the same practices or say sprint duration that you might see when you're designing, say, a screen or a backend service, right? It's a different thing. And so when you're looking at, say, sprint duration, maybe 2 weeks is too quick. Maybe you can't deliver things in a 2-week cycle. Maybe you need a 4-week cycle. That's okay. I think that you have to work on figure out what works best for the team and not to be afraid to say, look, I know we typically do 2 weeks. That's too quick. We're trying to deliver at the end. We need to make it 3 weeks. We need to make it 4 weeks, or we need to adjust parts of the process and to not be afraid to tweak it. Because Agile is really about taking feedback, not just from users on the end result, but also on the process itself, which is what the retrospective is for, and adjusting it so you can have success going forward. Okay, so what's the catch? That all sounds really great. Like Agile is awesome. You're going to meet with your users all the time. You're going to be delivering things constantly, but it's going to be super fun and easy. Everyone's going to be really happy. That sounds really great. But there's challenges, right? So when we're thinking about Agile, we don't want to deliver wheels and then a frame and then a car. We actually want to deliver like a little skateboard and then a scooter and then a bike and each of the car. You're trying to deliver something that people can use at each step of the way. But there are challenges that I don't think we see in typical software development around decomposing the model. How do we break this model down so it's actually iterable so that we can actually deliver pieces of it? They're often interdependent, and when you change one, you can affect the entire thing. So how are we delivering parts of a model, right? That sounds like you can't just deliver like 2 constraints and hope that works out. How are we defining done? What does it mean to be shippable for a model, particularly knowing the model doesn't have all of the data or all of the constraints or all of the objectives? What if the results don't look so great because of that? How do we define the success criteria for a sprint, which is a really important piece of the sprint to understand what we're aiming for when we know we're only going to do a piece of a model? And then how do we iteratively refine a model, knowing how complex they are and knowing that any small change can lead to a significant impact on the outcome. And for those who have made a tiny little tweak, even just you have the model and it's working great and you change the input data a little bit one day and suddenly it runs a lot slower or the result looks a lot different. I'm sure you guys have seen that in practice. So it's not so easy to just keep refining it. Again, it's not like a screen where you add a button one day and then you add this other button and then you add another, form or whatever. It really is one big piece that you're trying to decompose. And so this can be complex. And I don't want to undersell the challenges because it's not all fun and games and it's going to be super easy, but it is doable and achievable. But we have to understand going forward that there are some challenges. And really, because it's focusing on short-term iterations and models are like this long-term view, how do you mesh those up, right? So that you get a model at the end that's robust, effective, and meets all the needs, but you're still able to maintain the progress of Agile. Okay, so I built this all up and we're all hyped, and then I told you all the things that are going wrong, and now you're kind of like, "Oh, Patricia, what's going on?" Great. Now I'm all bummed out about how hard this is going to be and all these challenges. It's kind of a bit of a downer. And so let's talk about them and figure out what are some ways that we can approach this because we have faced this. We have ways to mitigate a lot of these things that we can bring into the process to help, and we just need to figure out, stepping through these challenges one by one, how do we address them? So the first thing, which I think is the most difficult, honestly, of doing Agile with optimization models is decomposing the problem. And this is very challenging. I think the other ones are more process, you can figure out done, you can figure out refining. Decomposing the model can be kind of a make and break, because what if you just can't decompose it, right? How would you then deliver it in a sprint? So there are two ways that we've typically been able to decompose problems. One is to divide it into subproblems. A lot of models actually naturally contain subproblems. And I do think sometimes as modelers, we have this idea that you've got to do this whole big thing together. Fair. And it is absolutely true that there will be times when you can leave out a constraint or an objective or a variable or something, and the results just don't make sense. 100%. Like if you had an assignment problem and you didn't have all those typical assignment constraints, obviously you're going to overassign people or underassign people. So there's absolutely cases that will happen. But there are times when you can definitely subdivide it out. Supply chain is an obvious example of this, where there are components of that problem. A lot of transportation problems can be decomposed like that. Um, if you can't decompose it, which it's nice to decompose anyway, because decomposing a model is a great way to solve the different pieces. You can also think about incrementally adding complexity. So again, a lot of times you might have your core set of objectives and constraints, and then there's this kind of like nice to haves or better. It becomes like these are the things you must have to make, the model work, to make sure you don't overassign people, overschedule people, violate various business rules or resource capacity kind of thing. But then there were other things we were thinking about, like maybe non-core resources or going from what you must do to what you want to do. And those can come in perhaps at a later time. And so those are two different ways that we can see in terms of decomposing the model so that you can deliver it in pieces. This sounds easy, and I know it's harder in reality. So what I wanted to do was just to give a couple examples of how we've done this, just maybe to kind of get your thinking about different approaches for this. The first, in terms of decomposing into subproblems, a couple problems that we've had. One was optimizing the fleet and crew for a fractional jet ownership company. This was a pretty big model. At the end, when it was all done, it encompassed planes and crew, and not just crew, but also how crew got there, which was on, third-party commercial aircraft. Um, but it also did day ahead planning, it did repositioning, it did recovery, day of recovery. So if a plane broke in the middle of the day, how do you actually handle that flight and recover for it? So that's a pretty big complex model that not only has multiple resources, but it also has multiple planning horizons. And so when we thought about decomposing it, we said, let's start with the day ahead planning. That's where you get a lot of bang for the buck. That seems like a good first place to optimize because it's a difficult problem. You can't see all the pieces in your head versus recovery. You can kind of see, you have to affect less pieces typically to do a recovery model. And so we first did the day ahead planning. Then we came back and we said, okay, let's talk about the plane repositioning and optimize that as well. And then finally we get into, okay, now we've got our plan for tomorrow and looks great. And then tomorrow something happens and it breaks. Now let's bring in the day of recovery so that we don't deliver all these different planning horizons at one time. We step through them in pieces, understand the pieces, deliver things that people can use because day ahead planning by itself is very useful. Repositioning is very useful. Day of recovery is very useful. All of them together, even more impactful. Again, I already gave the example of with the manufacturing facility, working through the staffing as a second thing. And so first optimizing the flows of the facility and assigning the machines, and then adding the staffing in when we realized it was needed, as well as some ancillary resources like the quality assurance group. We also did a model for the assignment of loads and drivers for a bulk chemical shipper. This is a really good place to decompose a problem when you're thinking about trucking and that kind of like VRPs and those kind of things, those kind of transportation models, because You can go ahead and do the what we call like the tours to figure out how you're going to group loads. That's often really the big bang for your buck is you're trying to group up like locations, so you're reducing empty miles, you're reducing deadhead, that kind of thing. You can do that, and then later you can think about, okay, now how do I assign those tours to the right drivers or equipment? And do I use third party or do I use my own? So this is a really good chance where you can say, let's focus first on getting the right groups of loads together, and then let's figure out who should take those loads. Because even grouping the loads together by themselves could really be a big help to the dispatchers because then they can assign them out or they can make the decision of third party or in-house operators. And so that can be just a big benefit to say, here's how you can like triangulate, here's how you can reduce empty miles, and you can figure out the staffing, and then later you can add that in. And then finally, working with a client on optimizing the operations within a rail yard, lots of sub problems in this. And I think there's not a tendency, but perhaps an idea of doing the whole yard together. You get the most optimal solution if you do the whole yard, but really it's a bunch of little problems, right? What tracks to use for an inbound, how to switch, how to make up a train, how to prioritize freight. Those are all sub-problems that you can do individually and piece together. They're all going to provide value by themselves, and then when you layer them together, they're going to provide even more value. So those are some ways that we've been able to decompose pretty big models into sub-problems. Looking at instead how you add complexity. So we'll go back to the fractional jet ownership. So first we talked about decomposing the time horizon into sub-problems. But we also looked at layering in the complexity in terms of the resourcing. So when you're looking at this kind of planning, really the plane is the most expensive piece, it's the most resource constrained piece. You only have so many planes, they cost a lot of money. So that was the first thing we did. What is the right plane for every flight? Then after that was done and we were able to deliver it and people liked it and they were using it, then we said, okay, let's look at the crew. What crew should we put on these flights? And there are rules around crew. Obviously, there's duty rules, whether people can serve together or not. There were even rules about whether they, what kind of aircraft they could fly. Obviously, they're only, qualified for certain aircraft. But then after that was done, okay, then the next thing is how do we get the crew to where they need to be? They're not always at the location of their first flight. We've obviously seen in airports, everyone's probably seen a crew coming from another flight running, trying to catch it so that we can get going on time. So crews are always being repositioned in commercial and in obviously fractional jet ownership. So how do you get them to where they need to be? That was using actually third party. They might fly on, a regular commercial airline to get to a place to then take their flight. So that was something that we could layer on. So we're adding in the complexity, not starting from day one saying, okay, let's build a model in which we assign the plane, we assign the crew, and we figure out how the crew is going to get there. In the example that I gave with the railcar network distribution and optimization, we looked at what was multiple objectives again, and we love multiple objectives. This is a great way to decompose. There were some pretty core objectives around demand and empty miles and unused rail cars. And then there were some secondary ones around allotment and some soft operating constraints. And so we were able to do kind of a V1 of let's do, we got to meet demand, we got to, minimize empty miles, rail cars, that kind of thing. And then once that got working, let's then layer in some of those other constraints and objectives that people have that they could do without, but it will make the solution look better to them and more manageable and more implementable. Going back again to our ad revenue ad slots, that again we talked about where we broke it down into the objectives and we did the first objective. And then we were able to add in, so was, minimum optimizing outcomes with a set budget. And then we were able to go back in and say, okay, what if we had some of these other goals with this new data that we need? Like we then want to say, instead of using a set budget, we minimize the budget. And so we were able to layer in more objectives, more complex data, more complex metrics into that after having delivered what was like the initial model that they really needed. And then for VRP, again, a really great place to decompose. There's obviously your hard and fast rules in a VRP. Like there's, obviously drive time. Those are the big ones, right? Hours of service and that kind of thing, rest. But there are often other objectives, customer windows, driver layovers, that kind of thing, equipment preferences versus requirements. And those can be added in later. And as you start to build up maybe the realism of the model and you start to say, okay, I like this, but we would do it differently. It's like it's allowable, it's legal, it's feasible, but I'd like to see this. That's when you can start to add those in. So those are some ways that we've been able to incrementally add complexity. And I think between decomposing problems into solved problems and adding complexity, you're able a lot of times to break the problem down into a way that you can start delivering and getting value to your users and following more of that agile process without trying to do a big bang at the end of it. So that to me is the really big one. It can be difficult to figure out how to do that, but hopefully these examples give you guys some ideas of how you might be able to do it with your own problems. A second challenge is defining done. And so done is really the agreement between the modelers and the team and the product owner about what is the criteria, because you want to say, okay, I am done with the sprint. The sprint has delivered what we said it would deliver. And I think this can be challenging with a model because with a screen, does it have the button? And if I push the button, does it do what the button is supposed to do? It can be a little bit harder with the model, particularly when you're doing it in an iterative nature, because it might not be fully complete. It's probably not going to be fully complete. Hopefully it provides a feasible solution. It's probably not going to be fully optimized in terms of this is my perfect solution. I'm going to go with it right now, because if it was, that would be the final sprint, right, of the agile cycle. So you are going to have these sprints in which you're giving people solutions that they might be okay with, but they don't love, or in fact, they don't even like at all. And that's part of the process of figuring out why they don't like it. But you have to understand that liking it is not the same as it being done, right? And saying, okay, I think it's completed. It's done what we said it's going to do. We've got this specific goal and we've made it. And then in the next sprint, we'll take on another goal and that will make it better. And so we're going to continually get better solutions rather than thinking from the very beginning, we're going to have the perfect, final, optimal, beautiful solution. This can be a challenge. I think it's a mindset challenge. And honestly, I think one thing that has kept modelers from wanting to engage users early in the process, at least for me, has always been the fear of if I show a user a solution and it's not perfect, and I know it's not perfect, and they know it's not perfect, they're going to give up on the model, right? Oh, this model is so stupid. It can't even solve this really basic problem. This answer is just not right at all. I can't use it. When you're doing waterfall and you get to that point and you show it to them, that's like a really bad feeling. You're like, oh gosh, this is like, I'm all done. When you're in Agile, that's actually to be expected. And it's really about setting expectations at that point. And so this isn't really a technical thing. It's not about how you formulate models or build models. It's really about how you and your product owner come to an agreement about how you're going to know that your sprint was completed, and knowing that a sprint being completed and a model being completed are different things. I think this comes down to experience working in the Agile framework and comfort in knowing that you have a roadmap, even if it's a little loose, to get there, and that you have the team willing to take your feedback and be flexible on it and work to improve it, and knowing that you will get there. If you have a client, I've had a client say this to me, I'm going to ask for everything I want right now because I'm not going to be able to come back for a round two. That was a waterfall problem. They wanted everything because they weren't sure if they were going to get another iteration on the model, a V2 on it. That's not the Agile mindset. There's going to be a V2 and a V3 and a V4 and a VN and a VN plus one. And so you have to come together with that mind frame and really work together. And it's about being a partnership and a team. And I think the Agile does a good job with bringing the product owner into the various sprint ceremonies so that you do see that kind of partnership and collaboration. And that's really how you, I think, can work together to define criteria so that you know, like, I am done with this sprint. This sprint was successful, because it doesn't always mean the same thing in modeling that it means in traditional software development. So it's kind of a mental one. And then something to also consider, though, is MVP, right? And that's enough to be usable and to provide value, but it doesn't mean it's the final thing. So every iteration is going to have its own definition of done. There's going to be a long-term vision of it. We're going to get there together, and just to have that understanding with the product owner. And then finally, this is more of I think, again, a technical challenge, but more of a process challenge. How do you iteratively refine a model and don't break it, right? It's very doable to just add a constraint and think everything's good and that constraint looks great, and then suddenly the model does not work like you wanted. Performance is obviously very common. You've tuned the model. A lot of times we don't tune it till the end because of that. But maybe you've tuned the model, or maybe it was working really great, and you thought, I'm just going to add this next constraint, and it's going to all be working together. It'll be great, and then suddenly things aren't working anymore. What are some ways around that? The first thing that we like to do is we like to have what we call a solution validator. This is one of our best practices. And what we do is we get someone on the team who is not the modeler. This person has not done any of the coding. They can look at the formulation. They understand the business. They do not know what the code looks like. They write a solution checker. And what that will do is it will run the solution through the business rules and make sure none of them are violated. This just helps us figure out whether the model is doing what it's supposed to be doing from an outside point of view. A bonus, you can run this on your existing solution. And if your product owner or business or client says they never, ever, ever do XYZ, sometimes you will, and you put a hard constraint to never allow XYZ, you will sometimes take their current schedule or their current plan or their current solution and you will run it through and it will fail the solution validator, which is kind of fun. Because a lot of times that's just not true, right? Very rarely do you say, I will never ever do XYZ unless it's something like a legal requirement. The next two really go together, and that's around testing. And this is something that I think the modeling community is getting better at, but still see improvement, which is to have a really rigorous and structured approach to testing. And two pieces to that are test harness that lets you do multiple runs very easily. And so we did this for a client, one of our very first Agile projects. We had a really nice test harness. We had a full test data set, and we were able to say, okay, these are the results. Like sprint one, here are the solutions. Sprint two, here's the solution. Okay, between sprint one and sprint two, we see a little bit of difference. And then we could go and look at them and see, okay, why were there differences? Is that expected? Oh, well, yeah, because we added this new constraint. And I do expect that to change this value here. Okay, that's cool. Okay, sprint three, we see another difference. Do I expect that? No, that doesn't look right. Maybe something has changed. And so being able to quickly and easily test with a lot of scenarios and test data is really key to figuring out whether the changes you're putting in are working as you expect and whether they have unintended consequences. And I do think this is something where I don't see it as much as maybe I would like to. You see this a lot in automated testing in typical software, like, you've got your Tricentis, Qtest, Tosca kind of stuff, JMeter, that kind of thing, where they're doing a lot of automated testing. It would be good to see more of this, I think, in the optimization space. And I think when you get into Agile, you really need to be able to kick off regression testing and these test harnesses really quickly because you just don't have a lot of time because of the sprint cycle to do this otherwise. And then finally, introducing new functionality slowly. So I would not every sprint just add everything in and then run it because you don't know then what's causing the changes that you're seeing. If you've got 3 constraints to put in a sprint, I would put them in one at a time and test them pretty thoroughly one at a time and see what their impacts were separately and then what they are together. And if it's something like you're adding a constraint that has setting a cost and the objective, you can set that cost to 0 and just see what it does, because if that affects the solution, that's an interesting data point because the cost is 0 at that point. And so there are ways that you can, I think, be really incremental and very structured about how you add things to make sure that you understand how each new piece is affecting the solution. That goes back to, though, knowing what the solution already should be, and that's back to your test harness and your test data sets. Okay, so that was a lot about how you can really incorporate Agile and what are some of the challenges and how to overcome them. I do want to address one more thing. This is our elephant in the room. I think what people are, in addition to not wanting to show results that they're not comfortable with, or the iterative nature and how do you decompose the problem, the other thing lurking in the back of every modeler's mind is, what if the model doesn't work? And I don't know it doesn't work until the last sprint because I've been kind of building towards that the whole time. And so it's uncomfortable to go into Agile sometimes and say, okay, I've got this plan for sprints, but I don't know if in the end the model is actually going to solve in time, can actually work, does this variable work, are these constraints going to work? And I will just say to this, I don't think that that is inherent to Agile. That's just unfortunately part of modeling. If you do it in waterfall, you're still not going to know till it's all done if it works or not. And so I don't think that should stop people from embracing Agile. It's uncomfortable. It's something that we live with. It's harder to know. Like, there's some models are just not going to work. Some techniques are not going to work. Sometimes you're going to have to change things. And I don't think that's any different than Agile and waterfall, other than in Agile, maybe you find it faster, maybe you find it slower, depending. But I don't think that is an obstacle to bringing Agile into the optimization space. And then finally, just a couple of final thoughts. Again, know where you're going, understand the business, do your homework. Just because we don't have this giant requirements in design phase does not mean you shouldn't be sitting with your users and really understanding what they do and why they do it. Embrace their engagement. Like I said, to me, this is the most important part of modeling. This is, to me, the holy grail. And so I like that that is actually a building component of Agile. Be realistic about time and resource commitments. There are more meetings in a way. They're more consistent. You're going to see your sprint schedule, and there's going to be a demo, and there's going to be planning, and there's going to be a retro. There's going to be your daily stand-ups, refinements, grooming. That's okay. You have to think that there are more of them, but they're more consistent versus being bunched up at certain parts of a waterfall cycle. There's definitely more frequent testing and releases, and that's when you really got to get to your CI/CD pipeline and make sure that's there. And then finally, something that I've seen from people is not just in the optimization space, but just generally with Agile, is the desire to skip the retrospective to save a meeting. I've heard this. I think this is a bad idea, particularly for optimization and particularly at the beginning of a project. You want to make sure your product owner feels heard, feels involved, feels like they're getting what they need. Your team is getting what they need. And so I would not skip retrospectives thinking you're going to save a half hour, an hour in a sprint cycle. You are missing a chance to have direct feedback from your product owner about what's working and what's not working. And so I would not say, let's not have that meeting because I don't want to have another meeting. I would just said, embrace it and say, what can we learn and how can we improve so that our product owner can work with us better and the team can work better because this is challenging. And the more we work together, the more comfortable we'll be with it. Okay. And that is all my thoughts. So I will thank you guys for joining. I hope that you learned a little bit about why we think you should embrace Agile for optimization. And if there are any questions, I can take a couple, I think.
Yes, folks. Thank you, Patricia, for that wonderful presentation. Any questions, please feel free to post them in the Q&A. There's a button, it should be at the bottom of your panel. There's one question, Patricia, that has
Mhm.
come in about tools. Are there software
Mm.
tools that you use during Agile?
Yeah, I mean, I think Jira is the biggest. I mean, they're definitely the market leader in Agile. Every one of our clients that does Agile uses Jira. There are other tools out there you can use and Jira is an Atlassian tool. Um, but it's a good tool. It's very flexible. You can set it up and configure it to what you need a lot of times. I will also make a plug for the AI component of the Atlassian tools, both Confluence and Jira. They're actually pretty good as a souped up search engine. But I would say 99% of what I'm seeing is using the Jira platform. It's very consistent.
Okay. Um, Here is another one,
Mhm.
kind of funny. Do you ever use waterfall anymore?
I don't think that we're using waterfall in any projects at the moment. That's not to say that we wouldn't. If so, we go with what our clients do with their tech stack and also with their methodology. So if a client said we do waterfall, or we wanted to do waterfall, we would say, yeah, we'll do that. We'll be happy to. If we get to pick, we will be doing Agile because I do think there's a lot of benefits to it, as we've discussed. But I don't at the moment have any clients asking to do waterfall, and I think that's because they're starting to bring like optimization and modeling is becoming a little bit less this thing on the side and more of an integrated part of their technology stack and their offerings and their applications. And most clients are doing that in Agile. And so they want to bring you into their processes, which are Agile.
Okay. One last one that I'm
Mhm.
seeing, and we have time. If you have a question, feel free to post. But one last one I have is, do you um, manage non-optimization software uh, uh, projects in addition to
Mhm.
optimization, as you've been talking about in Agile?
Yes. Oh, yeah, for sure. We do at our firm do things that are not optimization. I personally have some very large projects that don't always have a big optimization component. They're actually 99% not optimization just because they're very large projects. We're doing some software replatforming, for instance, that are large projects, and we are managing those in Agile. Those are multiple Scrum team efforts. Like we're talking, like 4 Scrum teams, 7 Scrum, whatever. And that's a really great way to manage those projects because you've kind of got these little mini teams and they're all working within their own product owner, Scrum Master kind of framework, and then all coming together like with PI planning and stuff. So definitely, well, I would consider Waterfall for an optimization project if someone really wanted it. I would be hard pressed to consider Agile for just a software project, just because I think there were some risks with Waterfall. And I think Agile is just a really great methodology in general. I think that you get a lot of value from delivering to your product owner on a cycle like that.
Okay, terrific. Well, thank you, Patricia. To the audience, we will be. Oop, I see one that just came in. Here's a question, Patricia. If
Mhm.
you have multiple developers in a team, then do you have to decompose the already decomposed problem to effectively divvy up the development work?
That is such a great question. I will say that's actually, I don't think that's inherent just to Agile. I think Waterfall would have the same problem in terms of how that's really about, to me, how multiple modelers work on a project. And that is kind of challenging, right? Because it's like you're all in the engine at one time, trying to tune things and tweak things. And so, yes, if you are going to have multiple modelers working on stuff, maybe they're actually working in different teams, they're working on different pieces. So you do need to think about how they're going to each touch pieces that maybe don't screw up what other people are working on. And I do think that that's a challenge with any kind of development methodology for optimization. It can be very hard to figure out a way if there's enough work, right, for multiple modelers. But I mean, there's data, there's working on different constraints, different objectives. You can usually pick those things apart. Even if you're delivering on the same sprint, different people can work on them and bring them together. You just need to allow for enough time for that integration, right? To make sure that they're all working together. Because again, if you got a button and a screen and a menu, that's one thing. If you've got a constraint and an objective and another constraint, how do those play together? You've got to leave enough time for it all come together and be tested together.
Okay. All right. Well, thank you again. So, Patricia, we will be sending out the slides and a recording soon. And if you want to discuss this topic or any other related, please reach out to Patricia. You see her email there on the screen. Um, and we look forward to talking with you or seeing you again, we hope. And have a great day. Take
Thanks,
care.
everyone.